David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, unit test review. As you know, you have a unit test coming up real soon. So this video is going to briefly go over all the topics we touched in the last weeks leading up to this unit test. So the first chapter we did was basic algebra. We did a bunch of things in there. The first part is we took expressions and went back and forth between words and expressions. So expressions and words. And we went back and forth. This is where we used words like sum and product and reciprocal and quotient. So for example, an expression might be R plus S equals Q. To write that in words, you'd write the sum of R and S is Q. So remember, here's a common mistake with converting an expression to words, is you would write out R plus S equals Q. That's just literally writing the equation in words. You need to take that extra critical thinking step of realizing what this is. This is a sum. So the sum of R and S. What is equals? Equals is just saying something is. So the equals becomes the is, and it's Q. Okay? So you got sentences like this that you had to convert this way, and you had expressions like this that you had to turn into words. So we spent a couple lessons doing that. Then we evaluated expressions. And what we did there is we had some expression like 6x squared minus 9 over 2. Let's say minus 9y over 2z. Something like that. And then you were told that x equals 1, y equals 2, and z equals 4. And you had to plug in your values and figure out what this expression would be. So let's do that. And there's a plug-in step. It'd be 6, plug in my 1 for x. That's 1, and it's squared, 6x squared. So there's 6, 1 squared, minus 9 times my y, which is 2. And then my 2z, z is 4, so that's over 2 times 4. And I encourage you to write your plug-in step out without doing any math yet. Now we can start doing our calculation. 1 squared is 1 times 6 is 6. Minus 9 times 2 is 18. All over 2 times 4 is 8. We're going to do the top subtraction. 6 minus 18 is negative 9. Over 8. Can I simplify that fraction any further? Nope. So we also did some combining like terms. This is an essential skill for all the algebra that we're going to do later this year, and indeed all of your years in high school math. So combining like terms, you have to evaluate all your terms to find out which are like. Now I have this trick that I showed before. I like to put symbols around the like terms first. So I have a 9xy, that's not an xy, that's not an xy, that's not a, oh, here's another like term. So I'm going to put triangles around those two. Let's see, do I have any x's? Nope. Yes, that's an x. So let's put a square around that one and a square around that one. Do I have any y's? Here's a 7 minus 7y, and I have a plus 9y. So let's put circles around that one. And then I have my constant negative 7, but indeed I don't have any more constants, so that's just going to ride on down. So now I can evaluate. I have 9xy's there, and I have negative 2xy's there, so that's going to leave me with 7xy. I have 8x's there, plus another 3, so that's plus 11x. and then I have a minus 7y with a plus 9y. That's going to give me plus 2y, and then I have my negative 7, and I bring that down. Now, once you master this, you don't need to use all these symbols to identify the like terms. But if you're struggling, this is a good step to do. So then we did products, where you had expressions like these three, and they were being multiplied. Okay, so let's take a look at these. When you have products, you only multiply similar things. So I'm going to multiply my negative 10 times my 6, and my x times my y. So I'm going to get minus 60 to the negative 10 times 6. I don't know what x and y are. They're multiplied, so I just write 60, negative 60 xy. That's how that one goes. Now this is a bit more complicated. We have some exponents going on. Still, I'm going to multiply my numbers. 2 times 44 is 88. Y squared and then times another y. That's really y times y times y, which is y to the third. That's how that works. Finally, this one's a little bit more complicated. I have 3 terms. Let's multiply my numbers. 3 times 6 is 18, times 2 is 36. And then I have r times s times s. There's only one r, so that's r to the first. We don't write the 1, but that's r to the first. I have s times s, so that's s squared. Now some of these problems got a little more complicated, but essentially that's what we did with those. Okay, let's take a look at the index laws. I put them all up here. Let's go over here. I put them all up there for you. These will be on the test. You don't need to memorize the laws, although if you work these problems enough, you're probably going to know the laws pretty well. Okay? So I've got the 10 that we've worked on in class, and they're all spelled out here in a general case. What we're going to do, I'm not going to go over the laws individually. I'm just going to start using them to do these problems. Okay? And then we'll do another set in just a sec. Okay? So let's take a look. And I organize these kind of to reflect the laws. X to the 5th times x squared. That's this law here. We just add the powers. So that's x to the 7. Okay? So, and guess what? If you want to pause the video right now and just work all these problems, you could do that. I'm going to keep moving. All right. So this one, when you have a fraction, you subtract the power from the top. The bases need to be the same. In fact, in this one, the bases also need to be the same. So this would be 2 to the 6 minus 4, which is 2 squared, which is 4. Okay? Now this one, this is a power of a power. So now we multiply the exponents. We get x to the 6th. This one, we distribute the power on the 2 variables in the parentheses to get x squared, y squared. Finally, this one, we do the same as distributing the power, but instead of on a product, we do it on a quotient. So this becomes 3 to the 3rd over x to the 3rd. And we know what 3 to the 3rd is. That's 27. So 27 over x to the 3rd. Okay, let's move on. Now I have a similar problem, but instead of variables, I've got a number down there. So this is going to be 3 to the 5th. And we know what that is. 3, 9, 27, 81, 243. And I don't calculate that fast in my head. I just know this number because it comes up a lot. There are certain numbers in mathematics that you will end up knowing just because of things like that. 3 to the 5th is 243. Okay, this one is going to be x to the 2x minus x, which is just going to be x to the x. Okay? Let's try that one. This is a power of a power. We just multiply 5 to the 3x. This last one is starting to get a little more complicated. I've got to distribute this power on both of these terms, and I'm raising these powers to a power. It's going to be multiplication. I'm going to get x to the 8th, y to the 12th. Exponents are arising. Okay, same thing. I'm going to distribute this exponent on the quotient, so I'm going to get, now this is tricky. Don't say 2x to the 3rd, because the 2 also is getting the power on it. So it's 2 to the 3rd, x to the 3rd, over y to the 3rd. And we know what 2 to the 3rd is. That's 8. So it's 8x to the 3rd over y to the 3rd. Okay, let's do a few more. Again, The laws are right there. Here are 1, 2, 3, 4, 5 problems. If you want to pause the video right now and see if you can do that. Let's see how they go. X to the 0. 0 power rule, don't forget that. That's always 1. So this becomes 1 over 2 squared is 4. So that's 1/4. Negative power rule. You take the negative power, where are we? We're right there. You put it underneath the fraction. So this becomes 1 over 2 to the 3rd, which is 1 over 8. Negative underneath. That's this law. Now we just bring it back up. So this becomes 6 to the 2, which is 36. One piece of advice is when you have variables, you can't turn them into numbers. But when you have a number to a power, always take it all the way out to whatever that number is. If you left it as 6 squared, you'd get some partial credit, you wouldn't get full credit. 9 to the 1/2. Remember, the 1/2 power is also the square root. We can write that like this. That means square root. But since we know what that is, the convention is we just write square root. The 2 is implied. And of course, you know the square root of 9, that would be 3. This one is a little bit more challenging. The 3rd power, that would be this law here. The n, 1 over 3, ends up being the root. So we talk about this one is, this is the 3rd root of 64. You might need to do a little thinking about that. What number times itself 3 times gets you to 64? Think about that. It's 4, because 4 times 4, that's 2 of them, is 16, times another 4 is 64. So this one is 4. So just like that one, 3 to the 5th, I know that. I've been there enough times that it's part of my memory. The same thing with this. The 3rd root of 64 is just 4. Okay, this one. Pause the video, think real hard, see if you can figure that one out. Okay, that's a trick question. It is. I wrote these in here to make it look like you could do a lot of canceling, a lot of reducing exponents down and things like that. But if you take a global look, a look at the whole problem, you'll see this big 0 power out there. So it doesn't matter what goes on in there. The answer to this one is just 1. Okay? Okay, let's take a look at expansion, the last chapter in this unit. We had a bunch of different rules. I'm going to go over 2 of them right here. The first one we did was the distributive law. This just says when you have something outside of parentheses with 2 or more things inside, you just multiply the outside by whatever inside terms you have. Some people are calling this the rainbow. If you need to draw your arrows there to keep track, that's great. So what happens is I did a times b, I got my ab, and my a times c, and I got my, it's not bc, it's ac. There you go. Okay, so let's do an example. 2 times x plus 1. As always, when I do videos, you can pause them and try to work it yourself. Let's see what that ends up being. 2 times x is 2x. 2 times 1 is just 2. Okay? Now, here's a more complicated one. Let's try that. Pause the video. Okay, so 6x times 2x. Multiply my coefficients, that's 12. Multiply my x's. X times x is x squared. 6x times 7 is 42x. Okay? The next pattern we got was the product rule, or FOIL. This is a really nice go-to for solving situations where you have one binomial times another binomial. Remember, FOIL stands for first, outside, inside, last. So first, multiply the 2 x's, I get my x squared. Outside, my x times my negative 4, that's minus 4x. My inside, 2 times x is plus 2x. And my last is 2 times negative 4 is negative 8. Now, when you do a FOIL, you will always have 2 terms in the middle that you can combine. These are like terms. I have a minus 4x and a plus 2x. So that's going to give me x squared minus 2x minus 8. Because minus 4 and plus 2 is negative 2. All right, so that's a pretty simple FOIL. Here's a much more complicated one. Pause the video, see if you can do that. Okay, first, 3x times 2x gives me 6x squared. 3x times negative 2 gives me negative 6x. 5 times 2x gives me plus 10x. And then 5 times negative 2 gives me minus 10. Now I have that middle step. I've got these two terms that are like terms. I have a minus 6x and a positive 10x. So that's going to give me a plus 4x. This will be 6x squared plus 4x minus 10. Okay, let's do two more expansion patterns. We've got difference of squares and we have perfect squares. And I want to say a little note about these patterns. These are things that have been discovered for a long time, and if you understand and can use the patterns, you can work more quickly, more efficiently, and have more control over how you do your math. And I don't know about you, but control is a good thing. It's better to look at a problem and say, I know how to control this, I know how to do this, than let it control you because you don't know what to do. Okay? So let's take a look at this first one. Difference of squares. Here's the pattern you need to recognize. One thing plus another times that same one thing but minus the other. Okay? If you see this written this way, you don't need to FOIL it. Because right, you could just FOIL this. You could do first, outside, inside, last, combine your middle terms. But since you can recognize that this is a difference of squares, you can skip that FOIL step and just write the first thing squared minus the second thing squared. It's super straightforward. So let's do one. Or if you want to pause the video, pause and try it. Notice how one thing plus another, one thing minus that same other. So this one's just going to be x squared minus 4. Okay? So first thing squared, we don't know what x is, so we just have to do x squared. But I know what 2 is. I know what 2 squared is. It's 4. So minus 4. Okay, that's a pretty straightforward one. Give that one a try. Okay, let's see how you did. First thing, actually let's talk about the pattern. These two things are the same, 3x and 4. It's just separated by a plus and a minus in each spot. So we can recognize that's going to be the difference of squares pattern. So square the first thing. 3 squared is 9. X squared is just x squared. And then 4 squared is 16. So it's 9x squared minus 16. Bam! Simple. One-step problem. Okay, let's take a look at the perfect square pattern. This one's a little bit more difficult, but I think if you dig into it, you can definitely master it. If you have a binomial, a plus b or a minus b, squared, then it's going to fall into this pattern. It's going to be the first thing squared plus twice the product of the two things. So it's going to be a squared plus 2 times a times b plus b squared. The last thing, squared. The only difference in these two is that if you have a minus between your two things, then that's a minus here, whereas here we had a plus between the two things, we have a plus there. Okay, so pause the video and see if you can do that one. Okay, let's see how you did. This is going to be first thing squared plus 2 times first thing times second thing. So 2 times the second thing gives me 6. The first thing is x, so I just have plus 6x. And then the last thing squared is going to be plus 9. Okay? All right, now I've given you a slightly more complicated one there. Pause the video, see if you can do that. Okay, let's take a look. This one's a minus, so we know that unlike this one where we had a plus, that middle term is going to be minus. So first thing squared, 2x squared is going to give me 4x squared because the 2 is also squared. I have my minus. Now it's 2 times 2x, which is 4x, times negative 7, which is going to be negative 28x. And then this one squared is 49. Now sometimes on problems like this where my terms are a little bit more complicated, I did this one in my head, but you don't have to. You could write a middle step for this that would be 2 times my a times my b. And that's going to give you your minus 28x. Okay, one word of advice. Students will recognize that you don't need these patterns to expand these. You can just FOIL them like you've been doing. However, you might bump into quiz or test questions that test your knowledge of these patterns. So don't just assume that you can FOIL all of these and ignore these expansion patterns. Plus, you could have a test question that says, expand these problems using difference of squares, comma, being sure to show that you understand the pattern. And that would require that you use the pattern. So don't ignore these and just try to FOIL those problems. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.